Welcome to the DIY Honda Garage channel. The diagnostic trouble codes DTC P00110, P0011, and P001B relate to issues identified in the intake air temperature (IAT) sensor system of the Honda Civic models from 2022 onwards. An IAT sensor measures the temperature of the intake air, which is crucial for the engine control module, PCM, to manage the air-fuel ratio and engine performance. If the PCM detects that the intake air temperature is beyond specified limits for a certain duration, it triggers one of these DTCs, signaling a malfunction in the sensor or its associated circuit. Understanding these codes is essential for technicians, as they indicate potential impacts on vehicle efficiency and emissions control. The effective functioning of the IAT sensor is vital not only for optimal engine performance, but also for compliance with emissions regulations. Proper diagnostics will ensure that repairs address the root causes of these codes. The error codes P0110, P0111, and P011B specifically address issues within the IAT sensor system. The intake air temperature sensor, often referred to as IAT sensor, is responsible for measuring the temperature of the air entering the engine. This information assists the PCM, or powertrain control module, in making necessary adjustments to the air-fuel mixture for optimal combustion. The IAT sensor is usually located in proximity to the mass airflow (MAF) sensor attached to the intake manifold or duct. When the sensor detects temperatures that fall outside preset parameters, it registers an anomaly, and the relevant DTCs are stored for diagnostic review. Recognizing the role of the IAT sensor and understanding how data is interpreted by the PCM is crucial for addressing these trouble codes effectively. Various factors can trigger DTCs P0110, P0111, and P011B, all primarily linked to the IAT sensor's performance or its electrical connections. A faulty IAT sensor is the most evident issue, where the sensor itself may be worn out or malfunctioning, leading to inaccurate temperature readings. Additionally, electrical connection problems, such as loose terminals or corrosion at the IAT sensor wiring harness, could disrupt the sensor's function and data relay to the PCM. Furthermore, any failures within the sensor circuit, including shorts or open circuits, can also result in performance issues signaling the stored DTCs. Thorough diagnostics are essential to identify the correct cause before proceeding with repairs. The symptoms associated with DTCs P0110, P0111, and P011B are crucial for identifying the impact of the IAT sensor malfunction. A common indicator is the illumination of the check engine light on the dashboard, signifying that the PCM has detected an anomaly. Drivers may also experience noticeable performance issues, such as reduced engine power or responsiveness, which can significantly affect driving comfort. Furthermore, an incorrect air-fuel mixture due to faulty temperature data can lead to increased fuel consumption, impacting fuel economy negatively. Additionally, emissions levels may rise, potentially causing the vehicle to fail inspection in jurisdictions with stringent regulations. All these symptoms necessitate immediate attention to ensure the vehicle operates efficiently and environmentally. The first troubleshooting step in addressing the DTC codes involves turning the vehicle ignition to the on position without starting the engine. This prepares the vehicle's system for diagnostics and allows the technician to begin inspecting the components for visual anomalies. It is essential to check the connectors at the IAT sensor as well as other related sensors such as the engine coolant temperature ECT sensors, and the MAF sensor. Any visible signs of wear, dirt, or corrosion can indicate potential issues. Additionally, a thorough evaluation of terminal connections will help identify loose or damaged wiring, which may disrupt the normal sensor operation. If any abnormalities are found during this step, repairs should be made before progressing to further diagnostics. In the second troubleshooting step, preparation involves removing the MAF sensor, IAT sensor, and allowing it to cool to the ambient temperature for accurate testing. This step is crucial as the operational temperature of the sensor directly affects its readings. After the sensor has cooled, the technician must reconnect the sensor's 4-pin connector without reassembling the sensor to the vehicle, ensuring it remains external for diagnostics. Next, the vehicle is turned to the on position again to allow the system to register the sensor's current readings. At this juncture, quick observation of the data from the Honda Diagnostics System, HDS, for the IAT sensor becomes necessary. Comparisons between the displayed IAT value and the ambient temperature will help determine if the sensor is functioning correctly. Upon obtaining the IAT sensor reading from the HDS, it is imperative to compare this value to the previously noted ambient temperature. The normal condition stipulates that the difference should not exceed 5.4 degrees Fahrenheit or 3 degrees Celsius. If the difference is greater than this set threshold, it indicates that the NAF sensor, IAT sensor, is likely malfunctioning and might require replacement. This comparison ensures that technicians accurately interpret the data and understand whether the sensor is providing valid readings based on environmental conditions. Addressing this discrepancy early in the process will help streamline subsequent repairs and minimize unnecessary replacements, thereby enhancing overall diagnostic efficiency. The final step of troubleshooting involves testing the IAT sensor's response to heat, simulating elevated intake air temperature conditions. After removing the sensor, a heat gun is carefully applied for a few seconds. This needs to be done cautiously to prevent damage to the sensor. The vehicle ignition is again turned to the on position to prepare for data evaluation through the HDS. Observing the sensor reading while the heat is applied allows for verification of the sensor's functionality under high temperature conditions. In a normal scenario, the reading should exceed 76 degrees Fahrenheit, 42 degrees Celsius if the sensor is operational. If the readings observed are below this threshold, it indicates that the MAF sensor or IAT sensor is defective and will need replacement or servicing. After completing the necessary repairs to address the issues causing the DTCs P0110, P0111, and P011B, the next crucial step is verifying that the repairs were successful. Using the Honda Diagnostics System, the technician should clear any stored DTCs to reset the vehicle's memory. Following this, a test run of the vehicle is imperative to ensure that the IAT sensor is operating correctly under normal driving conditions. During the test, it is essential to monitor the engine performance, fuel efficiency, and to check if the check engine light illuminates again. The vehicle should operate smoothly without triggering any faults, confirming that the previous issues have been successfully resolved. Successful completion of this verification step solidifies the repair work undertaken. Engaging in preventive maintenance is vital to avoid future issues associated with DTCs P0110, P0111, and P011B. Conducting regular diagnostic checks, particularly focusing on key sensors like the IAT sensor, can help in identifying potential problems before they escalate. Technicians should consistently inspect sensor connections for signs of wear or damage, ensuring robust electrical connections that foster reliable performance. Furthermore, Maintaining engine cleanliness not only boosts overall efficiency, but also extends the lifespan of sensitive components like sensors. Strategies such as periodic air filter replacements and ensuring proper intake airflow will benefit the entire intake system, thereby reducing the likelihood of sensor failure in the future. Incorporating these practices promotes longevity and optimal performance of the vehicle. In summary, understanding the roles of the intake air temperature sensor and the importance of accurate diagnostics is crucial in addressing DTCs P0110, P0111, and P011B. Effective troubleshooting steps, such as carefully inspecting wiring connections, conducting temperature tests, and analyzing data readings, are essential for proper identification of faults. Maintaining awareness of common symptoms, including engine performance issues or illuminated warning lights, will aid technicians in taking timely actions. Moreover, reinforcing preventive maintenance practices will contribute significantly to the longevity of sensors and mitigate future risk of reoccurrence of these DTCs. By following these comprehensive procedures and recommendations, vehicle performance can be enhanced while ensuring compliance with emission standards. Please like and subscribe to the channel. See you next time.